Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on antenna. Okay, so this video again will be so-called discuss on the various antenna parameters. This video, okay, I'm going to focus on the physical size and also the shape of antenna. Okay, how does the shape and also the size affect the antenna performance? So this will be the objective of this video. This will be the part 14 series discussion on antenna design. So guys, if you're keen to know more about antenna design, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on antenna. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are also welcome to ask me your question through the comment. Okay, before I continue, okay, I'd like to urge you guys to help this channel by like this video. Just give me a few seconds, okay, by pressing the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for your strong support. This slide here shows all the key parameters of antenna. These are those that I have already described in the earlier on video. This video, like I mentioned earlier on, I will so-called emphasize how does the size and also the shape affect the antenna performance. So basically, this will be the discussion of this video. Antennas, they actually comes in wide range of size and also shapes. Okay, so it actually depends on their intent use. What will be the frequency? Okay, so somehow the frequency will determine the wavelength. So keep this in mind. Frequency and wavelength, they are actually inverse proportional. High frequency, small wavelength. Low frequency, big wavelength. So basically, this is the key definition of just on the antenna here. So how does the size actually influence the antenna design? Okay, so antennas can be as small as a piece of wire. Okay, so nowadays, I believe more wire as compared to rod. So basically, nowadays, we have more antenna, wire antenna. Okay, for example, for our car radio, okay, the radio that we actually so-called install in a car. So basically, they are easily deployed by just wire antenna or as large as those that capture the satellite signal. Okay, so basically you can imagine how big the satellite dish. Okay, so basically that will be a huge size. And this piece of wire or wire antenna is considered quite a small size. Okay, the size of an antenna is actually determined by the frequency. Okay, and somehow, okay, it actually will affect the size of the wavelength also. Okay, so basically it is, for example here, okay, antenna for higher frequency, they need to have a smaller element so that they can fit within a given physical height. So basically, this is regards on the size of the antenna. Regards on the shape, okay, so antenna can be very simple or complex in terms of shape, depending on their use. For example, when we actually want to have a very directive antenna, okay, so therefore we will have a very narrow beamwidth in the shadow of a lobe. While omnidirectional antenna, we have something like more a very spear propagation. Okay, let's quickly understand on terms of antenna size. Okay, so antenna size, as I mentioned earlier on, is actually frequency dependency. Okay, which means that the frequency actually will affect what will be the size. Okay, the size of an antenna is actually related to the wavelength of the signal. Okay, for example, okay, antenna size is typically a fraction of the wavelength. For example, the antenna can be half of wavelength or a quarter of wavelength. This is what it means. Basically, it will be a fraction of the wavelength. Let's give you an example. Okay, for example, this is C equals to F lambda. C is the velocity of the EM wave propagation. Okay, for example, let's quickly just take it that it's the speed of light, which is 3 times 10 to the power 8 meter per second. This is the frequency, this is the wavelength. For example, okay, when we actually have a signal that is actually at 1 gigahertz, let's take the velocity as the speed of the light. So somehow the wavelength will be around 30 centimeter. Okay, so with this, okay, we know that the dipole antenna is actually half of wavelength. So therefore, the overall size of the dipole antenna, okay, they can be like 15 centimeter. So basically from here you can see that with frequency, I got my wavelength, and when I actually got my wavelength, I actually will be able to obtain the antenna length as you can see from here. Okay, so let's quickly understand what is actually large antenna, what is actually small antenna. Okay, as for large antenna, okay, you realize earlier on I mentioned that it's basically mainly used for low frequency. When low frequency, okay, we actually have a long wavelength, which means that the antenna is quite huge. For example, in AM radio. Okay, so this actually often quite impractical, okay, for very low frequency, okay, due to their large size. However, by having a large antenna, we can actually collect more power and also provide better signal quality. Okay, so basically this is for the large antenna. As for the small antenna, okay, so nowadays most of our devices are actually so-called portable. So we are getting more and more design in terms of small antenna. So small antenna, they are mainly used for high frequency signal. So we have high frequency, which means that we are going to have a short wavelength. Okay, for example, for Wi-Fi, okay, or 5G. Okay, so basically these are considered high frequency. So therefore, the size of an antenna will be very attractive. Okay, so we actually have a small antenna so that it will be easier, okay, to integrate into compact device. For example, our smartphone. Okay, so the dipole antenna actually consists of two linear conductor end to end with a length of half of wavelength, as you can see from here. So this is actually a dipole antenna. So basically, the length of the dipole antenna is actually so-called half of wavelength. Okay, the dipole construction actually consists of two lambda over 4 quarter wavelength element. Okay, so basically this is quarter wavelength. This is another quarter wavelength, as he mentioned here. Okay, so dipole construction consists of two lambda over 4 element, okay, end to end, okay, with a field in the center by a transmission line. So you can see that the signal is actually fed by this transmission line, and you actually have two quarter wavelength, okay, that actually make up as a dipole antenna. Okay, at resonance, okay, the antenna appeared to be at 73 ohms resistor. Okay, a dipole horizontal radiation pattern actually look like a figure 8. As you can see here, okay, so basically this dipole horizontal radiation pattern, they actually look like a figure of 8. Okay, in 3D, okay, the pattern is shaped like a donut, okay, with maximum radiation perpendicular to the length of the antenna. Okay, so basically you can imagine this is basically the dipole antenna. You can see that where is the direction of propagation is mainly, okay, so-called perpendicular to the length of the antenna. Next, okay, another popular variation of the dipole is actually the ground plane, or sometimes we know this as macaroni antenna. Okay, so it consists of a single lambda over 4 element, a quarter wavelength element here that is actually mount vertically, and it work with the earth or a metallic base. So this is actually a earth or a metallic base, which is called a ground plane. Okay, the ground plane antenna is just half of a dipole. Okay, so basically in short, okay, so earlier on I mentioned that for dipole is actually half of wavelength. Okay, but for this case here, okay, which is for the ground here, basically we just need to have a quarter wavelength over here. Okay, so the ground plane antenna, okay, basically this is what I mentioned, is just half of a dipole, okay, with the other element of the dipole actually represented by the ground plane. The polarization is actually vertical. Okay, keep this in mind. This is actually a vertical polarization, and the radiation pattern is actually circular or in a omnidirectional. Okay, so basically this is what I mentioned earlier on. So basically, as I mentioned, these are all mentioned here. So basically, the impedance at the base is about 36 ohm. Okay, and this is drive by this 50 ohm coaxial cable. So for example, let's say this is a transmit antenna. The signal actually travel at the coaxial cable, and then basically will pass on to the antenna, as you can see from here. Okay, so next, okay, we come to this patch or microstrip antenna. Okay, so basically this is very oftenly used at a higher frequency, or we call this a microwave frequency, typically greater than 1 gigahertz. Okay, so basically how does the shape? It can be a square or a circular patch of conductive material. Okay, so typically, okay, about half of wavelength across. So basically imagine this can be half of wavelength. This is also can be half of wavelength. So this is what you mean here. Okay, so create this is quite easy, okay, because it is usually implement on a PCB. Okay, the loop antenna is also another popular, okay, so-called non-critical application. Okay, so again, it's just a continuous loop of conductor wire or maybe even PCB thread. Okay, so basically a patch or microstrip antenna, okay, can be simply constructed by a PCB. Okay, at microwave or at very high frequency, it is easy to make array of patch to form a phasor array that will have gain, directive, and also the ability to incorporate beam forming and stirring. Okay, so basically you just imagine we have lots of patch antenna. Okay, so basically with that, we can have a better gain. Okay, we can also have a better directive because we can actually stir the beam. So basically this is for the patch antenna. Okay, so before I continue, guys, if you had learned something from this video, again, help me by like this video. For those, again, learn something, and if you are new to this channel, please subscribe and turn on your notification bell. Once again, thank you so much. Let's continue. Okay, so these are very common shape, and then where will be the application for this different form of antenna? Okay, so this is actually for dipole antenna. Okay, the size or the shape, okay, typically is half of wavelength long. So basically, you can imagine it's a wire. Okay, so it can be so-called half of wavelength long. So where they are actually used, there are many used in FM radio. Okay, so now we don't have AM radio. So basically now you can imagine the majority of this dipole antenna will be using for FM radio and maybe for some Wi-Fi router. Okay, so maybe some older type of Wi-Fi router. Okay, the new one, I guess we are not using dipole anymore. As for loop antenna, okay, they can be circular or maybe even rectangular loop of wire. Okay, so basically you can see that this is actually a rectangular loop of wire. So there are many used in RFID. Okay, not so much. We don't actually design much on AM radio receiver. Okay, I think this AM radio receiver has already phased out. Okay, next will be Yaki Udan antenna. Okay, so basically it is a linear arrangement of element. Okay, so basically you can see that this is a linear arrangement of element. Typically, okay, we use this to receive our TV program. So basically this is what it means. Mainly we are use this as a TV antenna and also some amateur radio. Okay, parabolic antenna. Okay, so they actually has a reflective surface, okay, that look like a parabola. Okay, basically they are mainly used in satellite communication and also radar. Patch antenna, okay, it can be flat, rectangular, or circular. Okay, which means that the patch design, they can be in a rectangular shape, as you can see from here, or maybe even circular shape. Okay, so this is actually nowadays commonly used in mobile device, for example, a smartphone, and maybe a lot of IoT application. Okay, so helical antenna, so they actually has a so-called a spiral shape. Okay, and this form is mainly used in space communication, long distance. Okay, let's discuss about the shape that will be impact in terms of the antenna performance. Okay, so basically the beam width and directive. Okay, so basically the narrow shape like dish, actually they are able to focus energy into a beam. Okay, so therefore they actually can provide a very high directive. Okay, so most of the satellite dish you can imagine, okay, basically they have a like a dish shape. Okay, so basically they are able to focus the energy into a very narrow beam, and therefore they can actually provide a very high directive. Okay, because when we actually want to send something to the satellite, okay, so no point to send in a so-called in a wide beam here. So therefore we can better focus, okay, as so-called, then we will have a very high directive. Okay, so board shape like dipole radiate more uniformly in multiple direction. Okay, so basically for another use case is, for example, we want to send so-called 360 degree, or maybe I should say that open bracket 360 degree. Okay, there's no such antenna that will be able to radiate 360 degrees. So I just do a open bracket 360 degree. Okay, so basically we will use a dipole. Okay, because they are able to radiate in a so-called uniformly, okay, in multiple direction. As for polarization, okay, we have vertical polarization, horizontal polarization. Okay, so therefore the shape actually will affect the E field orientation, and hence this will influence the compatibility with the signal source. Next, on the efficient and gain, okay, complex shapes like the fraction antenna, they actually maximize the surface area, improving the bandwidth and also the efficiency in compact design. Okay, as for the practical consideration here, okay, in terms of the space constraint, Okay, we have portable device that require very small and compact antenna. Okay, so therefore we have this chip or maybe even patch antenna. Okay, so as for the environment condition, okay, we have the rugged shapes like loop. Okay, they can be more durable in a harsh condition. As for multi-band, okay, so basically nowadays a lot of device has actually multiple band, so therefore we can have a multiple band antenna. Okay, so basically, for example, for log periodics, they can support multiple frequency shaped to resonate at various wavelength. Okay, so by balancing the size and shape, okay, with the intent operating frequency, environment, and also the application, okay, we as a designer, we can actually optimize the antenna performance for a specific need. Okay, so with this, I like to end my discussion. Okay, so this discussion I have discussed on the antenna size and also the shape, how this actually affect the performance of the antenna. With this, thank you so much. I hope to see you guys soon. Bye for now. Thank you.